Hello. So we are doing 10-1-2. How do I represent consistency? And what we're doing is talking about the box and whisker plots that we recently reviewed that actually come from the sixth grade content. And what we're going to do is sort of just take a step up from that introduction. Now, in the past, we've performed an experiment where the students played, quote unquote, golf. And so we had an imaginary hole on the floor, and the students would play 40 holes of golf by tossing an item, trying to get it as close to the hole as possible. And so some years we used dice, other years we used pennies, things like that. And some groups were more successful than others. So in your packet, you have a set of data for group one, group two, group three, and group four. And what we had was 4 students per group. Each student would take 10 tries. And so there's a total of 40 pieces of data per group. And then the students would take all of their data and they would represent their data in a box and whisker plot. So in order to do that, and this is the back side of the notes that I will reference occasionally, we would take a blank number line like this and set it up for 40 holes of golf. And each group would set up their data in numerical order. So group one would go 2 through 35 because their lowest distance from the hole was 2. And I think it was actually in centimeters, so that was pretty impressive. And then the furthest away was 35. We went through and said, okay, there's 40 pieces of data, which is an even set. So halfway is going to have 20 pieces on the left and 20 pieces on the right, making halfway between this 14 and 15. So first we had a median of 14.5. Everything below that line was the lower half of the data. So halfway would have been between the 9 and the 10. I don't know why that looks like a 19, but it's a 9 and a 10, which would have left us with a lower quartile of 9.5. Everything above the median would have been 20 pieces of data. So halfway between the 20 and the 24 would have been the upper quartile, 22. Last, the lower extreme or the lowest number in the data set was 2. The upper extreme, the highest number in the data set was 35. So we have a 5-number summary, 2 being the lower extreme, 9.5 is the lower quartile, with a median of 14.5, an upper quartile of 22, and an upper extreme of 35. We took that data and we put it onto a box and whisker plot. Now we did it for all 4 groups. So there's groups 1 and 2. I also have all of the same data worked out for groups 3 and 4. Went through the same process every time. The median was halfway. 40 pieces of data meant it was an even amount of set of numbers, and you had to find halfway between the 20th and the 21st number. In some cases, it was 2 of the same number, so the median was easy. Also for group 4, the median was halfway between 20 and 20, which made the median 20. You had to find your quartiles and last, your extremes. So what I have here is all 4 groups on the same number line. So group 1 at the top, down through group 4 at the bottom, you will notice that there are certain things that need to be present for a box and whisker plot. First is a title. So 40 holes of golf results. We were finding the results of each group playing 40 holes of golf. Then I have the box and whisker plot, and underneath each piece of data from the 5-number summary, I have the number listed. So it's not just a blank box and whisker plot. It actually has values under each one of those 5 points, making up the box, the median down the middle, and the extremes on the ends. So here's where we get a little bit more into the data. It said, how can I represent consistency? So we asked the students in the past to say, what are the most important things about your group? So if I look at the sets of data here, I might look at group 2 and say, group 2 was very consistent compared to the other groups. And you would say, well, Mrs. Fraser, how do you know that that group was very consistent? They have the smallest box and whisker plot. Their range only goes from 2 to 16. They have a range of 14 centimeters. So their closest to the pin was 2. Their furthest away from the pin was 16. That's a very small range. I can also see that the box is very small, meaning that there was a lot of data clustered between 7.5 and 11. So that group would say we were very consistent. We had very low numbers. We were close to the pin often. Group 1, you could say, they weren't as consistent, but you will notice that the spread of data was fairly equally distributed. Like I don't have one massively long whisker compared to a very, very small section in the box and whisker plot. The spread of the data is pretty fair, I would say, amongst each of the 24%. And I'm sorry, 25%. So remember the lower whisker worth 25% of the data, the lower half of the box worth 25% of the data, the upper half of the box worth 25%, and the upper whisker with 25%. So if we look down here at group 4, we can see that group 4 has this really, really long upper whisker because they probably had some sort of gap in their data. So group 4 probably had maybe one person who had like a couple bad shots or maybe even just one bad shot, because otherwise the middle 50% of the data is pretty tight. I would say group 3 and group 4 had similar consistency, because you'll notice that the boxes are very similar in size, but that group 4's middle 50% was lower. And when you're talking about golf, you want a lower score, you want a lower distance from the pin. So the least successful group, I would say overall, is probably group 3. Their numbers sort of cluster around the highest values. But if you want to talk about the least successful person in general, they were in group 4 up here with the 50 centimeters away from the pin. Now, the next step, and you'll notice that it's not on the notes. It is not on any sort of filled in notes that were typed up. We're going to talk about outliers. How do we find if there is an outlier in the data set? So anytime there's an outlier, we're talking about one or more values that lies significantly outside the rest of the data. There is a process. There is a system for finding outliers. First thing that you need to do when you're finding outliers is find the IQR. The IQR, or interquartile range, is the difference between the upper quartile and the lower quartile. So here, the upper quartile is 22 and the lower quartile is 9.5. So I would do 22 minus 9.5. And I would say that this set of data has an IQR of 12.5. The difference between the top of the box and the bottom of the box, the upper quartile and the lower quartile, or you could say how wide is the box? If I do 22 minus 9.5, I get an IQR of 12.5. So that's step 1 for finding outliers. Step 2 for finding outliers is to multiply the IQR by 1.5. And it's always 1.5. What you're doing is saying, is there any data point that's more than 1.5 boxes away? So if you think about how wide this box is and you were to go like 1.5 boxes away, are there any points that are more than 1.5 boxes away? 12.5 times 1.5 is 18.75. So you're saying, is anything more than 18.75 below the box? So if I were to take 9.5 and take away 18.75, I'd be way down here in the negatives. And there's nothing in the negatives, so I don't need to worry about that. If I added 22, so this is my last step here. If I did 22 plus 18.75, I would have to say, are there any points above 40.75? Meaning, did anybody in group 1 have a distance that was 40.75 or higher? That's going to be my cutoff. Anything that number or higher is considered an outlier. And we didn't. There's nobody that high. The highest number is a 35. So in group 1, we would say there are no outliers. And you don't actually have to write it, but you do have to check for it. So visually, if you did a quick scan and you said, are there any points that are more than 1.5 boxes away? The one that should show up very quickly is group 4. Everybody should be looking at group 4 going, yeah, I'm pretty sure group 4 has an outlier. So if we look at that, step 1 is to find the IQR. 23 take away 18 gives me an IQR of 5. The width of the box is 5, or we can say the distance from the upper quartile to the lower quartile is 5. Step 2, multiply that IQR by 1.5. Again, it's always times 1.5. That's never going to change. So 7.5 is my distance. Is anything more than 7.5 away? So I have to check both the upper and lower ends. So I would have to do 18 take away 7.5. Is anything lower than that? Is anything lower than 10.5? And we would say, well, yeah, 10 is. So 10 is an outlier. So how do we make that look like an outlier? Anything that is an outlier gets an asterisk. So the 10 would become an asterisk because it's an outlier. And I can do that in another color because that highlighter is not showing up very well. Just give me a second to grab a better color. So I would say that 10 is an outlier. And then I have to look back at my data for group 4 and see what is the next lowest number in group 4 that comes after that 10. So in group 4, there's a 10 and the very next number is 11. So what we would do is we would make that whisker stop at 11 and you would have a gap. You would actually have to go in this case, because it's printed on my page and I can't erase it, there would have to be a gap here where you would say the whisker actually ends at 11 and we have an outlier at 10. Now, I'm sure most of you were actually looking at the upper whisker going, well, the upper whisker has a huge gap. It's really, really long. So there's probably a cutoff there as well. If we take the upper quartile, 23, and we add 7.5 to that, we would get 30.5 as another cutoff. So anything higher than 30.5 is an outlier. Clearly, 50 is an outlier. If we look at group 4's data, there's a 50. The next highest number is 28. Now, 28 is within the cutoff. 28 is lower than 30.5. So we're going to turn 50 into an outlier with an asterisk. And then we're going to look for the next number in the list, which was 28. So 23, 24, 26, 28. We're going to put a dot there at 28 because that's the next lowest number that's actually in our data set. And then we would erase or never have written to begin with the rest of that whisker and just show that there's an outlier. So what that does is it better represents the data for that group. Group 4 was actually very consistent with this one really weird outlier. Group 4, what happened? They had a very consistent group, but they had one penny that rolled and it just kept rolling. And so they had this one very strange outlier that they had to deal with. So what we end up with here are cutoffs. Anything outside of 10.5 and 30.5 becomes an outlier. So this group 4 actually had 2 outliers. They had one number that was significantly lower than the rest, technically an outlier, even though it might not quite look like one, and 50, which is definitely an outlier. We would probably want to just check the other ones to be sure. This one is 3.5. The range for the IQR is 3.5 and times 1.5 is a difference of 5.25. And if I add 5.25 to 11, that goes past 16. And if I take away 7.5 minus 5.25, we get 2.25 as the cutoff. So technically on group 2, as absolutely silly as it is, that 2 is actually an outlier. And in group 2, the next lowest number was a 3. So there's going to be this very, very small gap, just like we had on group 4, where we would have to say, okay, 3 was not an outlier, but 2 is an outlier. I did that one in my head. You can see I didn't write it down. And then this one, the IQR for group 3 is 5. And then if I do 5 times 1.5, anything that's more than 7.5 away, so 30 plus 7.5 would make that 38 an outlier. If I look at group 3, the next closest number before the 38 is the 34. So that means that the top number on my box and whisker plot, once I get rid of that outlier, should be a 34. And then I would white out anything between those two, making group 3 look a lot more consistent again, just like getting rid of the outlier in group 4 made it look much more consistent. And then this was a 7.5. So if I do 25, take away 7.5, my lower cutoff is 17.5, which is below the 18, leaving the 18 as just a regular number and not an outlier. So being able to find outliers really changes the look of a box and whisker plot and lets you know just how consistent they really were without having your data sort of skewed by one random rolling penny, because group 4 was much more consistent than their original box and whisker plot showed. If you look on the back of the notes, you will see that there is a reference sheet that has a number of vocabulary words and things on it. It does go over again how to find box and whisker plot, goes over that 5-number summary, reviews IQR interquartile range. And then at the bottom, it just lists off some other ways to display data that we've done in the past: scatter plot, dot plot, which you probably haven't done since sixth grade, histogram, box plot, which also does the 5-number summary. That's box and whisker plot or box plot. They often go by either name. Bar graph and circle graph, which are very common introductory graphs for students when they're first learning about ways to display data.